Good morning, sir.
Good morning. So, we have just finished two approximation method. First was a variational principle, and second was the WKB approximation. The variational principle have some different approach. It will just go to optimization of parameter, and WKB approximation will have some semi-classical theory of the intuition of some semi-classical theory, and we have tried to figure it out what will be energy eigenvalue for different type of system, and these all are just a basically approximated solution. And let's go for a next approximated method, and that is known as perturbation. So we will just go for first non-degenerate perturbation, and then we will go for degenerate perturbation. So, what are the basically meaning of perturbation? The meaning of perturbation is disturbance. So, question is that disturbance in what? So, disturbance in some original system. Now, the question is that what is meaning of original system? Meaning of original system is that the system which can be solved fully with the help of Schrodinger wave equation. So let me explain you what I am going to do, which kind of system that we are talking about. And there are limitation in a perturbation also. So what are these limitations? So first we will talk a basic concept, then we will just go for the mathematical uh, argument or mathematical analogy of using perturbation. Okay, so let's go for this. For example, suppose I have a spring mass system. So if I am talking about I have a spring mass system, that means I have a system which is harmonic oscillator. So okay, this is the system, this is harmonic oscillator. The Hamiltonian of harmonic oscillator is all about px square by 2m plus half m omega square x square. So these are the Hamiltonian of harmonic oscillator. Now, what is this is the Hamiltonian of harmonic oscillator. So how can we represent this thing as quantum mechanically? So obviously we will solve this Hamiltonian and we will get the quantum mechanical result. And what will be this quantum mechanical result? The quantum mechanical result is energy eigenvalue, that will be En, and that is known as n plus half h cut omega. And there is associated eigenfunction, and that eigenfunction is n ket, and this n ket can be written is a function of Hermite polynomial into e to the power minus omega x square m omega x square by 2h cut. So what we have? So we have this harmonic oscillator means, and this is the omega, this is mass m. So these are the parameter. If you know this parameter, I know the energy eigenvalue, and that will be n plus half h cut omega, and this will be En. And I know the psi n, and psi n I can write n ket, and this n ket is nothing but proportional to hn alpha x e to the power minus alpha x square by 2, where alpha is equal, this is proportionality sign, this is not alpha. So alpha is equal to root under m omega upon h cut. So we know this story. This is mass m. Suppose what I am going to do, I will put the mass, I will put the charge q on this mass, and I put the whole system in a electric field. Let's say this electric field is E naught. Then what will happen? This charge will feel some extra force. And what I am doing, I am just disturbing this particular system. So I have initially Hamiltonian H is equal to px square upon 2m plus half m omega square x square. This Hamiltonian we have, and we have just put the extra term, and that extra term is q e naught into x. If it is positive, then this will be negative sign. So this will be the extra term we are putting in this Hamiltonian. So after putting this extra term, what will happen to system? This is the role of perturbation. So this is our original system. Why we are saying is it is my original system? Because we know the energy eigenvalue and eigenfunction of original system. This is unperturbed system, and unperturbed without disturbance, we know the exactly how we can solve the energy eigenvalue and eigenfunction. And this particular thing I can put minus QE upon minus Q into E naught as some lambda. So this will be some lambda into X. This lambda into X, I can say this is the perturbed Hamiltonian. This is the perturbation. This is the disturbance in the system. So what I want the complete solution of a system. I want the complete solution, the whole system. इस पूरे system का हम solution चाहते हैं. But it is best way that you can solve the Schrodinger wave equation and you can get the answer. That is the best way. But it is not always simple to solve any problem analytically. So what we will do, we will just go to solve this problem with some different method, and this method is perturbation. And perturbation method is nothing but the Taylor expansion. So now, what is our main purpose? Suppose this electric field will be very high. Then what will happen? Suppose this electric field is very high compared to this restoring force. Then what will happen? This charge will feel force and it will just go into this direction. So it is very obvious that system will be entirely different system. I am saying that what we want this lambda must be very, very small. Why we want this lambda will be very, very small? Because I want that this system must behave just like as a harmonic oscillator. Maybe it can just shift its equilibrium point, or it may shift its equilibrium point and it may vibrate about some another point. Maybe it can shift some angular frequency, but the actual thing, it remain harmonic oscillator. But what will happen if I will increase the electric field very high? Then what will happen? The restoring fields will be overcome by the electric field, and it will become the another system. So I am not allowing that my system will become another system. Rather, what I allow that there will be some little bit of disturbance. So this kind of situation we want means this lambda must be very small. And which type of solution we want? I am saying my system must behave just like as our original system. Means I can represent the whole solution in a basis of original eigenfunction. What is the main idea? Main idea is that we need to represent the eigenvalue and eigenfunction represent means calculate. Represent means I am just want to write calculate. Calculate the eigenvalue and eigenfunction in a basis of eigenfunction of original Hamiltonian or unperturbed Hamiltonian. So can anybody tell me what should be the known thing into this one? This in this problem? What should be the known thing into this problem? जिससे कि आप फाइनल आंसर निकाल पाओगे? Can anybody have any clue?
Alpha, sir.
Sir,
Alpha? Alpha?
actually,
The known thing, listen, first known thing is the what will be your perturbed Hamiltonian? So this will be the known thing. What is the second? This will be given into the examiner. What will be second indirectly known thing?
एनर्जी सर अनपर्टर्ब्ड की
Unperturbed की एनर्जी और उसकी आइगन फंक्शन. ये तो हमें known होगा ना? Because what is the idea? Idea is that we need to represent the eigenfunction and need to calculate the eigenvalue in a basis of original Hamiltonian. So what is the, so this is the indirectly known thing of the original Hamiltonian. So what we need to do, using the concept of original Hamiltonian or using the result of original Hamiltonian, we will just represent or we will just calculate the result due to perturbed Hamiltonian. So this is the idea behind that. And which will help in this is nothing but the Taylor expansion. So let's formulate all this thing. I will not derive it fully, but I will give you glimpse of concept, how we are going to approach. This is very simple approach, not any rocket science. A very simple approach. Using Taylor expansion, we can get all this particular thing. Okay. Up to this, if you have any doubt, you can just ask me. Then I will go for next level of formulating non-degenerate perturbation. And it is the simplest topic. Why it is simplest topic? Because we have done a lot of thing into our core course, the postulates, the all about different type of system. Okay, so let's go for calculus, just formulation of this particular thing. And why we are saying it is non-degenerate perturbation? Because original Hamilton, the eigenvalue of original Hamiltonian is non-degenerate. So we are saying it non-degenerate perturbation. And if it will be degenerate, we will use it degenerate perturbation. That is different issue. But right now we are concentrating ourselves onto the non-degenerate perturbation. So let's go for this. So what we have H is equal to H naught plus HP. What is H naught? Unperturbed Hamiltonian. Unperturbed. And HP is perturbed Hamiltonian. Okay. And I can write this HP with some parameter lambda into W, where lambda is parameter and this lambda is very, very less than 1. Why it is less than 1? Because I want that my system can be represent only in a basis of original Hamiltonian. Because if lambda will be higher, then effect of this will be change. So this will dominate to this potential. This is going to dominate the original potential and you have new system. So if you have entirely new system, For example, I can again give you one more example. Suppose I have particle in box. This is infinite box. And I can give the little bump. So, okay, this bump is very small. So we can use the perturbation because more or less it will remain the particle in box. But what will happen if I will take this bump something like this? Then obviously this is an entirely new system, isn't it? This is entirely new system. This is one box, this is another box. So this is a new system. So in this case, you cannot use perturbation. Bump is always there. Bump is always there. But here you can use perturbation. That's it. This kind of situation I am talking about. Now, what we know, we exactly know this particular thing. H naught phi n is equal to En naught phi n. I am using the different notation H naught, so En naught. So this is known to us. आपने solve किया है. What will be this phi n? What will be En in particle in box? N square pi square h cut square upon 2m. What will be phi n? Root under 2 upon a sine or cos depends on situation. Yes. For the harmonic oscillator, En naught n plus half h cut omega. And what is phi n? Phi n is nothing but n ket or n ket आपको पता है क्या है. So we can use all this thing. So in the non-degenerate, more or less case is the particle in box and harmonic oscillator. That's it. Mainly the thing will become more complicated into degenerate perturbation. And what we want to solve? We want to solve h psi n is equal to En psi n. Need to solve. This is very simple. What is the idea? The idea is that we can write psi n as a Taylor expansion. So we have different order of lambda because in this side we have lambda. So we have different order of lambda. So this will be phi n0 plus lambda 1 psi n1 plus lambda 2 psi n2 and so on. And we have En also written as En0 plus lambda 1 En1 plus lambda 2 En2 and so on. What is the idea? Idea is that we have to calculate En1, En2 and psi n1. Only these three things we can calculate. Psi n2 is very complicated. This is not in your course. So we have to calculate. What are these terms? So when, so this is not lambda 1. Sorry. There is not lambda square. Okay. So this will be phi lambda square. So this is a Taylor expansion. And we are having different order of lambda. So this is unperturbed, means when lambda is equal to 0, then you will get this one. Very simple. That's it. What is psi n1? What is En1? En1 is known as correction in energy up to order of lambda. Correction in energy up to order of lambda. It is also known as first order energy correction. Correction in energy up to order lambda in nth state. In nth state. So this is nth state. One is correction in energy up to first order, means up to first order of lambda. It can be also written as first order energy correction. This is known as first order energy correction. So similarly, can anybody tell me what will be En2? En2 को क्या कहेंगे?
Second order energy correction.
पहले इसको बताइए, पहले ऊपर वाला बोलिए, ऊपर वाले को क्या कहेंगे? Correction in energy up to order of lambda square. Agreed? In which state? In nth state. So we will tell it correction. पहले लैंग्वेज सीखना जरूरी है, तो अपने आप प्रॉब्लम हो जाता है. Correction in energy up to order of lambda square in nth state. इसको शॉर्टकट में क्या कहते हैं? सेकेंड ऑर्डर एनर्जी करेक्शन. नाउ कैन यू प्लीज टेल मी, नाउ एक चीज और बच रहा है, दैट विल बी साई एन वन. बताओ तो इसे क्या कहेंगे? एनीबॉडी कैन टेल मी आफ्टर इसको देखने के बाद? किसके अंदर करेक्शन है ये? दैट इज करेक्शन इन वेव फंक्शन up to order of lambda in nth state. So this is the whole idea. ये सारी definition है. Now what we will do? We will put this h psi is equal to En psi. So what you will do? I am just giving the hint. I am not going to unnecessary calculation. We will put this particular equation here, this En here, and again this psi here. So you have a huge lengthy equation, and then what you will do? You will just equate the coefficient of lambda and lambda square on both sides, and you can get the En1, En2, and psi n1. This is the whole idea. You can just compare the coefficient of lambda square and multiply it with the suitable wave function of phi m. So iska use karke, when we will use it, we will multiply it this and we can get this answer. So this derivation is not needed right now. What we need, what will be En1, En2, psi n1, and how we will apply into this different system. This is the main thing we are going to use it. Okay, so let me give you the actual answer. So this is the definition part. What will be the outcome? I am just going to write in the next frame. So are you able to understand what I am going to say?
Yes, sir.
Okay, so very simple method, don't worry. So आप खुद भी कर सकते हो इसको. psi n को यहाँ put किया, En को यहाँ put किया, फिर psi n को यहाँ put किया, and you will take the coefficient on everything, and you will get a 3 and 4 equation, and using this particular term you can get the value. Okay, so don't worry. So let's go for, so I have this equation. I am removing all this one. So En1 is basically written as very simple phi n w phi n. That's it. What is this? क्या है ये? Can anybody tell me what is En1? This is nothing but the expectation value of W on phi n. That's it. This is come to En1. So this is the correction into energy due to perturbation up to order of lambda 1. Next, psi n1. This is little bit interesting. Here we will go m is not equal to n, and we have phi m w phi n, and you have En0 minus Em0. Here is phi m. What we have written? We have written psi n1 in a basis of phi m, means, and this is phi m is the eigen value. But we have to make sure that m will be not equal to n. Means if I am talking about ground state, then m will be first excited state, second excited state, third excited state, and n will be remain the ground state. If I am talking about first excited state, then n will be 1 for this is first excited state, then m will be ground state, second state, third state, and so on. And what we are doing, we are just writing psi n1 in a basis of eigenfunction of original Hamiltonian. That's it, nothing else. Now, if you can do this, you can easily find it En2, and this En2 is equal to m is equal to not n, and same formula you are using. We will just go phi m w phi n. We will just take mod square, and here is En0 minus Em0. That's it. Simple. Can anybody tell me for the ground state, can I claim En2 is less than 0 or equal to 0? I can claim. Are you satisfied with this? For the ground state, Eg2 is less than and equal to 0. Can you justify the answer? You can just talk me something. Okay. Can you justify this answer? Yes, you can justify. For the ground state, what will happen? This term is always positive, and hence it is ground state. So n is the ground state, and these are the all other excited state. So this number will be always negative. This number will be always negative. So it will be 0 when this term is 0. Otherwise, this will be always negative. So what you will find? You will find for the ground state, second order perturbation, second order energy correction will always negative or 0. In 1 year, this will be asked into one exam. Okay. So you have to keep in mind how we can do the analysis. And this is nothing but the average value. Okay. So if you have any doubt in the notation or formula, then you can ask me. Otherwise, we will just go for different types of problem. Okay. So let's go for using this formula in different, and please, these are nothing but the eigenfunction, and these are known eigenfunction, phi n, phi m. You know all these things. So let me go for one basic problem such that we can understand all this notation, and then we will go for a different type of, and you will see within a 5 minute we are able to solve all problem once we know the notation, because we have done all the calculation with ourselves. So there is not any rocket science. How smart you are, this is most important thing. So let's go for this. So let's me give you H is equal to E naught 0 0 minus E naught plus lambda 0 V naught 0. So this is the thing. So this is H naught and this is V naught, where lambda is less than 1 and E naught is greater than 0. Okay, so E naught is positive. And I am just giving the notation. This is very important. N is equal to 1 represent ground state and N is equal to 2 represent first excited state. Okay, because I am making some hypothetical calculation. So N is equal to 1, I have given this is for the ground state, and N is equal to 2 is for the first excited state. Now, first question is the trivial. Find E n0 and phi n. What is meaning of that? You have to just calculate the eigenvalue and the eigenfunction of unperturbed Hamiltonian. Means you have to basically calculate E10, E20, phi 1, phi 2. Means you have to calculate this one. Second, this is interesting. You have to calculate E11, E21, psi, and third you have to calculate psi 11, psi 21. Fourth you have to calculate E12, E22. What is meaning of that? Here you are going to calculating what you are going to calculating here. First order energy correction in ground state and first excited state. Here first order wave function correction in ground state and first excited state. Here first order, second order energy correction in ground state and wave function. Okay, so we can do it easily because we know all this formula. But the main thing, what will be En1? Sorry, this all thing. So can anybody tell me? I am just giving you 30 seconds. Just calculate this part. Then this part I will calculate. Just calculate this one.
Sir, lambda equal to plus minus E naught.
Lambda is equal to आइगन वैल्यू इसकी बात बताओ, इसकी बात बताओ. E10 क्या होगा? What is E10?
Minus E naught.
Minus E naught. That is minus E naught. Isn't it? Because what I am saying, N is equal to 1 represent the ground state. So minus E naught is the lesser than E naught. So you have to recite E10 is minus E naught. This notation is very important. And what will be E1?
E naught.
E20. E20 is equal to E naught. So first you have to identify this one. Unless until you are not going to identify this one, this will be very dangerous. Now, what will be your phi 1? Can anybody tell me what is phi 1?
1 0.
1 0.
Zero
No,
one.
0 1.
So negative, na?
Yeah.
Negative nahi hai. If you are going to solve this eigenvalue, you will get the eigenfunction corresponds to minus E naught is 0 1.
Okay, sir.
भाई आप जब सॉल्व करोगे तो नेगेटिव होने से कुछ लेना देना नहीं है. Agreed? The eigenfunction corresponds to minus E naught is 0 1. And what will be this? Here phi 2 is equal to 1 0. So I am deliberately giving this question such that you are doing such that you have to understand the role of this notation. Because a lot of people will write E1 is equal to E naught, E2 is equal to minus E naught, and similarly 1 0 and 0 1. No, you have to calculate this particular original Hamiltonian, and then you will get what will be your eigenvalue and what will be your eigenfunction. Are you getting this thing? I think you know how to solve this thing. Matrices are over. We have done a lot of things, है ना? So just जाओ और जाकर के solve करो. You will find this is your eigenfunction, and you will always calculate the unperturbed Hamiltonian as normalized eigenfunction. You can easily see. So let's try to go for all other calculation. Okay. So what I have all this non-thing. E10 is equal to minus E naught. E20 is equal to E naught. And phi 1 is equal to 0, 1. And phi 2 is equal to 1, 0. This is the non thing. And now we have to calculate E11 means we have to write phi 1 W phi 1, and it will be phi 1 is all about 0, 1. This is W. You will write 0 V naught 0, and that will be 0, 1. You will calculate this value is 0. If you are able to calculate, you can easily calculate this value is 0. So what is meaning of that? There is not any change up to order of first order. So this is this kind of perturbation. It may be 0. There is not any change. You can easily calculate this particular thing. Second, you will calculate E21. What should be this? This will be phi 2 W phi 2, and this will be 1, 0, and you have 0 V naught 0, and there is 1, 0. This will be again 0. Don't worry. Next, we have to calculate psi 1, 1. The formula is m is not equal to 1. And what we have to do? We have to write phi m W phi 1, and here is E10 minus EM0 phi m. This is the value psi 1, 1. Now, can you please tell me what should be the value of m?
0.
Hmm?
2, sir.
Why 0?
2.
2, sir.
2, only 2. There is only 2 values allowed, either 1 or 2. So if I will take m is not equal to 1, here is 1. Then m is not equal to 1. Then you have to take 2w phi 1. That's it. Only these are there. Isn't it? इसको समझना बहुत ही ज्यादा important है. Because what is your formula? Your formula is psi n1 is summation over phi m w phi n, and here it is en0 minus em0 phi m. So now you can compare it, and m is equal to not n. You have to write m is not n. So if I will write, what are the possible value of n? The possible value of n is 1 and 2. Only 2 possible value. So if I will write n is equal to 1, then m should not be 1. Then only one case is there, m will be 2. So what will be this particular thing? So this can be written as psi 1, 1 is nothing, but this can be written as, so m is equal to not 1 means m is equal to only 2. So you have phi 2 w phi 1, and here you have E10 minus E20, and here you have phi 2. And now we will calculate it. What is phi 2? The phi 2 is 1, 0. What is W? 0 V naught 0. What is phi 1? 0, 1. So this is the calculation. divided by E10. What is E10?
Minus E
Is
naught.
minus E naught minus E20, that is E naught. And what is your phi 2? Phi 2 is your 1 0. And if you are going to calculate this particular term, this term will come to V naught. Okay. So psi 1 1, this term will calculate. You can easily calculate this term. V naught by minus 2 E naught 1 0. This is your correction into first order. Okay. And once you are able to find it, you can easily find En1, En2. What will be En2? Or En2 is nothing but summation over, you have same thing, phi m, w, phi n, and you will just take this thing mod square. Here is En0 minus Em0. And here again m is not equal to n. So this is the same thing you are using. So can you please tell me what will be E12? So if we are calculating it, we can easily write this thing. इसको देख करके बताओ क्या होगा E12?
minus V naught square.
So this will be written as m is not equal to 1. So you have to write phi m w phi 1 mod square, and this will be E10 minus Em0. M is not equal to 1 means m is only 2. So this will be En2 is equal to phi 2 w phi 1 mod square. You have taken E10 minus Em0. What will be this value? This value is nothing but V naught. So this will take you mod square, and this will be, sorry, E12. And this value is equal to minus 2 naught. So what will be this value? So this is V naught upon minus 2 E naught, and this will be mod V naught square. Okay. This is the value, isn't it? Minus sign is there. So this is energy into second order. Okay. So I am just giving you 30 seconds. Just calculate psi 21. Just calculate psi 21 with yourself. Then I will calculate, because at least one question you have to calculate with yourself. Just go for it. Then we will take a break and we will just go for next level of calculation. Okay. Just calculate it.
Sir, V naught upon 2 E naught.
V naught upon 2 A naught. And what will be this function?
Yes, sir.
वो कौन सा फंक्शन होगा?
Zero.
Zero.
0 1
0 1
0 1
0 1. वेरी गुड. चलो मैं फिर कब करता हूं, फिर आप वो भी कर लोगे, है ना? So at least everybody have calculated, or you need
Yes,
some
sir.
more time? Okay. Okay.
Sir, done.
Done. So let me use a very shortcut to save my time. So now how thing are going to change? So first you have to write the formula again and again. So we have to write psi 2 1. What is meaning of that? Summation over phi m w phi 2, and here we have E20 minus Em0, and that will be phi m. What is m is not equal to 2? Suppose it will be 3 cross 3 matrix, then how many term will be there?
2.
2 term. If it is 4 cross 4 matrix, then how many term will be there? 3
3
term. Because 1 term we are just leaving. Very good. Now you understand. So now we have to just, if I am writing this thing, then this is, the m is not equal to 2, so there is only one option, m is equal to 1. So phi 1 w phi 2, and here you can write E20 minus E10, and this term is equal to phi 1. Now put all these value, and what will be this value? Phi 1 is equal to nothing but 0, 1, and this will be 0, V naught, 0, and this will be 1, 0. And here E2 0 is equal to E naught, E1 0 is minus E naught, isn't it? And what is phi 1 is 0, 1. And if you are able to calculate all this thing, this value is equal to what? This value will be V naught. So I am writing here because I will use that thing there. So that will be V naught upon 2 E naught, and this value is 0, 1. This will be E to 1 into this problem. Now, how it is going to change here? How it is going to change here? This is same formula. This will change E to 2. So this is 2 here. This is 2 here. This is 2 here. And now you will write this is 1. This is 2. This is 2. This is 1. And what you will get? You will get E 2 2 is equal to V naught square upon 2 E naught. And you have find that ground state energy had negative second order correction, isn't it? So this is all about thing. You can verify it. Now this is so simple example that you can take this, you can completely solve this energy eigenvalue, and you can take the Taylor expansion. You will get exactly same answer. You will get exactly same answer. But I am not going into that because I am using the perturbation. If you will solve this thing completely and take the Taylor expansion, you will get exactly same answer. Now, how you are going to write the answer? So answer can be written as E1 is equal to E10 plus lambda E11 plus lambda square E12 and so on. So what is E10 is minus E naught plus lambda E11 is 0. So you can get some number also, but in this problem it is 0. And lambda square E12 is minus V naught square upon 2 E naught. That's it. This is your answer. This is your approximated value of complete solution. And similarly, you can write psi 1. Psi 1 is equal to phi n 0, and this will be lambda psi 1 1. We get this phi 1. So this will be phi 1 0. What is phi 1? Phi 1 is equal to 0 1 plus lambda psi 1 1. We have calculated that is V naught minus 2 E naught into 1 0. Isn't it? So this will be your psi 1 approximated value up to order of lambda. So you have this value, but in the examination they will always ask what will be this one, what will be this one, and how you are getting this particular thing. Okay. So this is the first level of perturbation, non-degenerate perturbation. So take a break of 5 minutes, and then we will go for a next level of all this calculation. Okay.